Now we continue with question 7. A double slit source is separated from a screen by 1.4 meter. And the distance between two slits is 0.040 millimeter. The second order bright fringe m equals to 2 is measured to be 4.6 centimeter from the center fringe. Okay, if you see this question, this is about young double slit, right? Because this is YDS case. Okay, it's separated from the screen, so this is the D. The distance between two slits, so this is a small d, right? And the second order bright fringe m equals to 2 is to be measured to be 4.6 centimeter. This would be the ym. Okay. Now we have to determine the wavelength of the light. So we have to determine the lambda and also the distance between the adjacent bright fringes, that is delta y, right? Okay, let's take out all the information that is given here. We have D equals to 1.4 meter, okay, and D equals to 0.040 millimeter. Now we have to change it to meter. That's 0.040 times 10 power of negative 3 meter, right? And then we have the order, second order bright, that is m equals to 2. And delta y, that is, and the distance from center fringe to the second order bright fringe is 4.6 centimeter. That is ym equals to 4.6 centimeter. That is 4.6 times 10 to the power of negative 2 meter. Right. So we have to take out all the information now using the correct formula. So which formula are we using? Okay, since we are going to find the lambda, so we are going to use formula ym equals to m lambda d over d. Okay, and we can rearrange the formula. That is lambda ym over md. That is 4.6 times 10 power of negative 2 meter, okay, times 0.040 times 10 power of negative 3 meters, divided by number of order, that is 2 times d is 1.4. Okay, so you should get the answer 6.57 times 10 to the power of negative 7 meter. Okay, where can you get the marks from here? Okay, so the marks will be given for G1, that is Gantian 1, and JU1, that is jawapan unit. And then you got the correct answer and the correct unit, that would be 1 mark. Okay, so that would be 2 marks. Okay, and then we are to determine the distance between adjacent bright fringes. 7A2. Okay, we have formula delta y equals to lambda d over d. Okay, so we just substitute lambda with 6.57 times 10 power of negative 7. That's what we have here. Okay, and then d is 1.4 meter. Okay, divide by 0.040 times 10 to the power of negative 3. So we will get delta y equals to 2.3 times 10 to the power of negative 2 meter. Okay, where can you get the mark? Okay, you can get a mark from gantian jawapan unit 1. So, total of 3 marks. Okay, that's for 7A. Next, we move on to 7B. Okay, given a camera lens coated with a thin film of magnesium fluoride to eliminate certain reflected light. The refractive index of the magnesium fluoride and lens is 1.38 and 1.5 respectively. If the minimum thickness of the thin film is 75 nanometer, determine the wavelength of the eliminated reflected light. Okay, so what the first thing we need to know is what is the case for these questions. Okay, so since it's mentioned here about thin film, so automatic you can figure it out that is a thin film case, right? And for thin film, we have to determine whether it is in phase or anti-phase. Okay, so we have to determine that first, right? So what should we do? We have the n equals to 1, that is the air, right? So this is the air. This is the thin film, that is magnesium fluoride, and the other one is the lens. Okay, so thin film n equals to 1.38, lens is 1.50. So, alright, for the reflected light rays, okay, so there will be less than to more dense, that will be pi red phase change. Okay, and then from here to here, okay, so from thin film to lens, that will be less dense to more dense, so that will be another pi red phase change. So pi minus pi, that means 0. So that means it is in phase. Then we have determined first it is in phase. Next, we have to determine whether it is constructive or destructive interference. From the questions here, we can see that it is to eliminate certain reflected light. What that means? It means that the light is gone, missing, right? So that means it is a destructive interference. Yeah? So destructive interference. Okay, and then given the minimum thickness, yeah, of the thin film, so they give you the T equals to 75 nanometer, that is 75 times 10 power of negative 9 meter. Okay, so that is the minimum thickness. Okay, now we have to determine the wavelength of the eliminated reflected light. So we have to determine the lambda, right? Okay, so in this case, we have determined that it is in phase and it is a destructive interference. Okay, so we use the cross pair. So C, C, D, D, right? So in phase, anti-phase. Okay, for in phase, destructive, 2 and T equals to M plus half lambda, okay, for in phase constructive 2 and t equals to m lambda. Alright, so for this case, you know that it is in phase and it is a destructive interference. Therefore, we use this. Okay, we use this equation. Yeah. So the equation is 2 and t equals to m plus half lambda. Since we're using the m plus half, we can use the m equals to 0 to get the minimum thickness. Okay, so just substitute. Okay, so 2 n is for the thin film, that is 1.38. Okay, the thickness given is 75 nanometer. Okay, equals to 0 plus half lambda. So lambda would be 4.14 times 10 to the power of negative 7 meter. Okay, where can you get the marks from here? Okay, so the marks will be from K1, G1, and JU1, right? So that total mark is 3 marks. Okay, for next questions, 7C. Okay, so light of wavelength 500 nanometer is directed perpendicular to diffraction grating. So we know that the case is for diffraction grating. Okay, given the lambda, and then the first order spectrum is at 22 degree. Okay, so omit this, right? So this is the theta, right? From the 0 order spectrum, calculate the number of slits per meter on the grating. So we are to determine the number of n, right? Okay, so let's take out all the information given. We have lambda is 500 nanometer. That would be 500 then negative 9 meter, right? And then we have the angle 22 degree and n is 1 over d, right? Okay, so we have to determine the d first. Okay, so what is the formula that we are using here? Okay, so we use d sine theta equals to m lambda, right? So d sine 22 degree equals to m is since it is the first order, right? So this is the m equals to 1. And so this is 1. Okay. Lambda is 500 nanometer. So we get D equals to 1.33 times 10 to the power of negative 6 meter. Okay. After you get the D, and then we can use the formula 1 over D to get the number of slits per meter. That is N equals to 1 over D. That is 1 over 1.33 10 power negative 6. So N is equal to 7.52 times 10 to the power of 5 slits per meter. Okay, that is all. So where can you get the marks here? Right, the marks goes to gantian here. So G1 This is JU1, second mark. And then the other one here is G1, that's Gantian 1, and JU1. Okay, that's all, okay, for question number 7.